Hello, I'm Aayush Joshi and I will be explaining you some questions today. This will be the outline. Question 1, then execution. Question 2, question 3, execution, and then the concept. Data wrangling in question 4. The first question is write a program that will print out words with W, I, C, and L in it, or the words starting with these alphabets. The sample input is given. So let's see the code for it. I have used a sample input and stored it in a string variable with name st. Then I split the content in the variable st with spaces and stored the result in a form of list in variable lst. This will break the string into individual words that was separated by space in the original string st. Then for loop runs till there are elements in the variable lst, till there are variables in lst. Then the if statement checks for words that start with alphabets w, c, I, and l. Then the words that start with the four variables will be printed. Either of the four variables will be printed, and if they are not starting with the four words mentioned in this, four alphabets mentioned in this, then the word will be ignored. We will not print it. So let's see the output for it. So this is the output for it, and you can see all the words starting with W, C, I, and L are printed. Let's move to our question 2. What are the important responsibilities of a data analyst? The responsibilities include designing and maintaining data systems and databases. This includes fixing code errors and other data related problems as well. Mining data from primary and secondary sources, then reorganizing the data into in a format that can be easily read by humans as well as machines, using statistical tools to interpret data sets, paying particular attention to trends and patterns that could be valuable for diagnostic and predictive analyst behavior, preparing reports for executive leadership that effectively communicate trends, patterns, and predictions using relevant data. Collaborating with programmers, engineers, and organizational leaders to identify opportunities for process improvements, recommend system modifications, and develop policies. This is more important. Develop policies for data governance. Let's move to the third question. Perform linear regression analysis with least ordinary squares using stats model package. So this is the program for it. This is the code for it. We have imported NumPy. We have imported NumPy as NP, and then we have also imported statsmodels.api as SM. So we will not write NumPy, complete NumPy, or this a whole thing, but we can write NP dot something or SM dot like database we have imported. So that is used for a shortcut method. Then we use the Spectre data set from sm.datasets. Then we use the load function to load the data from Spectre dataset and store it in Spectre underscore data. This exog and and ndog gives the value of x and y respectively. So in this, we declare a model with sm.ols. OLS should be in caps or in uppercase. So this spectre underscore data dot ndog gives the value of y values, and spectre underscore data dot exog gives the value for x. Then we fit the model in variable res through mod.fit function. Then we simply print the summary with the function with res.summary function. Let's see the code for it, output for it. So this is question 3, linear regression. When we run this, we get a nice formatted summary for it. This a nice formatted summary for regression results. Let's move to question number 4. So my topic is data wrangling. Data wrangling is the practice of converting and then plotting data from one raw form into another form. The aim is to make it ready for downstream analytics. Uh, there are 6 basic steps for data wrangling: data discovery, data structuring, data cleaning, data enriching, data validating, and data publishing. So let's see codes for a few of these steps. I'll zoom a bit so you can see the code. So here's the code. We import pandas as PD, like we did for NumPy and stats models API, and gave them a nickname. You can say a nickname. So we can use it further in the code as a shortcut. So we import pandas as PD. Then we declare a dictionary with variable name data, and we give them names like names, gender, dictionary with a number of inputs, like with a number of data with of name, age, gender, marks of different students. Then we construct a data frame from the dictionary data, and print it. We store the data frame in df and then print it. So this will be the output for this, and you can call this data discovery. Like we don't have any data set with us, so I just gave declared a dictionary. So you can say this is the way you would discover data or organize it. Okay, so data structuring. uh, in the first part, in this part, we are finding the average of marks. So we have declared a variable c is equal to average is equal to 0. This basically what it does is it initializes c and average both equal to 0. This is a short form of writing it. Then we run a uh, for loop in the data frame and in the column of marks. The loop will run as long as there is data in the mark section of the data frame df. Then we check if the string str bracket ele is numeric. As long as the value in marks is numeric, it will uh, it will execute these two steps. Then it will execute. If it is numeric, if it is not numeric, like in this case, in the mark section, we have NaN, so that is not numeric, and in this case too, it is not numeric. So it will not run statements, these two statements for these two cases. For all the other statements, when the marks is numeric, it will run it. What does these two statements do? It increments the value of c, which we earlier initialized as 0. It will increment that value by 1, and it will store the value in average. Average is equal to average plus ele. So it will add all the values of these marks, all these marks, 100, 96, 85, 65, and 71, and store it in AVG at the end of this for loop. Then this will count the number of ELE or marks which are numeric, and this will store the sum of all of them. Then we simply find the average, dividing total marks by the total number of marks, like values. Then we simply in this we do data frame dot replace. To replace, we replace NaN, which were present in this two NaN. We replace it with average. The average we found here, we replace them. Uh, we replace NaN with the average. So let's see the output for it. See, there was NA in this and in this mark section. So it is replaced by the value of average 83.4. NaN is replaced by the value of average, that is 83.4. So you can say this as data cleaning, or you can say it like you are replacing the missing values and you are giving them some value so that your program don't collapse or don't stop while running. Then we are doing a simple thing here, like we previously had gender as M, or F, M for male and F for female. So now we are converting that to in numbers. So in this we do df bracket gender, because we are targeting the gender part of the data frame, and then we use the map function. We map M as 0 and female F as 1. So wherever there is M, we will have 0, and wherever there is F, we will have 1. And we give the type as float. So instead of going only 0, instead of M, we will have 0.0. We will have it in float. 0.0 and 1 as 1.0. Let's see the output for it. We print it with simply writing df. We don't need to write print bracket df. This will also do. So see, as we have had the first 5 as m, we now have 0 0.0 in the case, 0 from here, and 0.0 from this float here, as we gave it the type of float to this. And wherever there was f in the last two, we have 1.0. So in a way you can say we were cleaning the data. uh, we might have used this m on f, but that would be like really not helpful, or that would not be convenient for writing code. So we converted it into 0 and 1. So you can say that we were cleaning the code and making it more machine readable. So here we do what we do. We are separating, or we are enriching the data we already have, pre-existing data. In this, we are doing data frame is equal to data frame bracket data frame dot marks is greater than 1. It is simply, you can say we are writing this is equivalent to if df bracket marks is greater than equal to 85. This is exactly the same thing as this. We are checking if the marks in df, uh, whichever marks in the marks, whichever number in the marks section is greater than 85, we are only storing that. In this, we have a variety of marks varying from 100, 96, 83. So we will have only those that are greater than 85, and all these 71, 65.71.0, 65.0, 83.4, everything will be erased. That will be neglected, and only the values greater than or equal to 85 will be stored. That is 100, 96, 100.0, 96.0, and 85.0. Let's see the output. And here we also drop we do one more thing. We also drop the age column. The age column that we had, we drop that column, and this is access. We have access 0, 1, name is at access 0, age is at access 1, gender is at access 2, and marks is at access 3. So we want to drop the age access, and that is at access 1, age column at access 1. We are dropping that. that with df.drop data frame dot drop function. So in this we are importing pandas in PD details as PD dot data frame. We declare another set of details with another set of another data frame, and in this we are having this is a, you can say this is a dictionary, right? This is a dictionary with you will have these columns as ID, name, and branch, and we are having a dictionary. Then we are converting that into a data frame, and when and then we simply print it. You can see it is converted into this dictionary is converted into a data frame, and this is printed pretty well. So this is data validating, and we do the same for this. We are declaring a dictionary here, and then converting it into a data frame and storing it in fee status, and then simply printing it. And in this, we are again declaring these two fees that we declared earlier: data frame, two data frames, details, and fee status, and then we are simply merging it, both the data frames. And uh, we are having a common column, so we are merging it with on id. So this will be shown only once, else it would have been shown twice. And when we run it, we will see id column is, it was twice here, once here and once here. If you will have normally merged it, then it would the id column will would have appeared twice. But when we are doing on is equal to id, one is equal to id, then the id column is showed only once. This is the output for it. Thank you. These are the references. I took a reference from pandas data frame and stats models. These are the links for it. Thank you. That will be it for today. Thank you.